Do you all see what is there? Please let me know.
Yeah.
Yes, we can see.
Good. Thank you so much. This one is to the newcomers, those who have just joined us today. My name is Alira Daniel. I'm your teacher for physics and mathematics, but as per now, we shall be discussing physics. Welcome to our Senior 5 physics lesson, which started a week ago, and we are discussing heat and thermodynamics. Just a recap of what we saw. We said that heat is just a form of energy that transfers, that moves from one point to another due to the temperature differences between those 2 points. Where I gave an illustration, we said that if you want to know that heat is flowing from one point to another, consider 2 points, point A and B, where I gave an example. Point A is at 20 degrees Celsius and point B is at 60 degrees Celsius. From there, you say that if we have those 2 points and they are joined together, then we expect heat to flow from point B to point A. That is from a point of higher temperature to the point of lower temperature. And we also discuss what temperature is. We say temperature is just a number that expresses the degree of hotness of a body on that very scale. That's what we said. We said the temperature is measured using an instrument called thermometer. And in a thermometer, there are some physical quantities, properties which are used. And those physical properties which are used in a thermometer, we gave it a special name, and that special name was thermometric properties. Those who are present, can somebody define for us thermometric properties? Raise up your hand, I will pick you. Thermometric property. Yes, Benjamin. Thermometric properties.
Thermometric properties are physical properties which vary linearly and continuously with change in temperature.
Very good. Thank you so much. Very good, very good, very good. So those are that's the definition of thermometric properties. We said these are properties which vary not just linearly, but also continuously with the change in temperature. We gave examples. We said one of them is the length of mercury glass thermometer. We said it is also variation of EMF in a thermocouple. We said variation of resistance in platinum resistance thermometer. We gave very many examples. We went ahead, we defined fixed points, and we said we have ice point and steam point. Then we talked about temperature scales, where we said there are 2 types of temperature scales. Who can give us the first one? Temperature scales. You can raise up your hand. Derek Amanya. What did you say temperature scale were? Derek, examples of temperature scales? Who can give us? Raise up your hand and I pick you. Yes, magnificent. I don't know whether that one is your name. Magnificent. I don't know whether that one is your name, but I think it's an English word. Yes?
I have essential scale and thermodynamic scale or Kelvin scale.
Kelvin scale, very good. Kelvin scale or thermodynamic scale. Kelvin scale is sometimes referred to as thermodynamic scale. So those are the 2, Celsius scales and thermodynamic scales. We saw how to establish a Kelvin scale, thermodynamic scale, where we said if you are to establish a thermodynamic scale, what you do, you first choose the thermometric property. Let's say X. After choosing the thermometric property, say X, you measure that thermometric property at ice point. Then you call that one to be X naught. You measure the thermometric property at steam point, which you call it to be X100. Then you put the thermometric property in an enclosure whose temperature theta is required. And then you measure that thermometric property at that point, you call it to be x theta. Then from there, we said theta is then calculated from, who can give us that expression of theta now? Theta is calculated from, you can raise up your hand. Theta is calculated from, yes, Alfred Okema. Alfred.
Theta is equal to, open bracket,
Yes.
theta minus theta naught, or of theta 100 minus theta naught times 100 degrees Celsius.
Very good, very good, very good, very good, very good. Man, you make sure you start looking for admission for campus. Is that okay, Alfred? Start looking for the admission.
Yeah, thank you.
So that when we resume school, you go direct to campus. You don't need to again wait for your name. So theta is given by x theta minus x naught over x 100 minus x naught then times 100 degrees Celsius. Thank you so much. So today we are going to establish temperature scales, but not Celsius scale. We are going to establish thermodynamic scale. So we are saying setting up Kelvin scale. Setting up Kelvin scale. So before we set up Kelvin scale, we can define what a Kelvin scale is. We are saying a Kelvin scale is the temperature scale which uses triple point of water as a fixed point. You remember we defined Celsius scale. We said a Celsius scale, somebody send me WhatsApp number, that is Derek Amanya. Derek Amanya says, I can't hear you. Derek, can you hear me now? Derek? Hello, Derek? Can the rest hear me?
Yes, sir, we can hear you.
Yes,
Good.
teacher,
That means that the problem could be with him. Derek, you check on your network, then you'll be okay. So I was telling you, we define Celsius scale. We said a Celsius scale is that type of scale where the fixed points, that is ice point, is at 0 degrees Celsius and steam point is at 100 degrees Celsius. That is what we said to be Celsius scale. But you're saying Kelvin scale. A Kelvin scale is that one which uses a triple point of water as a fixed point. Is that clear, everyone? It uses triple point of water as a fixed point. So Celsius scale uses ice point and steam point as the fixed points. But here, there's only one fixed point. Remember, we said a fixed point is the temperature at which physical changes take place. So we saw triple point. We said the triple point is the point or is the temperature at which water, pure vapor, and pure ice can exist at equilibrium under specific conditions. And the specific conditions, or a particular condition there, was that the pressure must be a standard atmospheric pressure of 76 centimeters of mercury or 760 millimeters of mercury. So when you're talking about Kelvin scale, when we're establishing a Kelvin scale, we need to know that it has only one fixed point. And that fixed point is the triple point of water. Triple point of water, we denote it as X we denote triple point of water as X T small r. Do you see what I've written? Is it
Yes,
visible? Good. So we denote it as XTR. Now, if I want to establish triple point of, if I want to establish Kelvin scale, just like how we established Celsius scale. For Celsius scales, we chose, remember, we chose the thermometric property. Then after choosing the thermometric property, we measured it at the two different fixed points. We measured it at two different fixed points. At ice point, remember that one we called it to be X naught. We measured it at steam point, we called it to be X 100. So likewise, here, if we are to establish Kelvin scale, we also choose the thermometric property. We can call it also to be X. Then after choosing X, we measure it at the fixed point. And this fixed point is triple point of water. So we choose the thermometric property, we say X. Then we measure the thermometric property at triple point of water. Then we call it XTR. Then we measure the thermometric property at a known temperature, which we are looking for here, which we can now call it to be X theta. Then, after measuring a triple point of water and measuring at the unknown temperature, we determine the unknown temperature from the expression. I can write that expression. From the expression, we determine theta from the expression theta equals to X theta over X T R times 273.16 Kelvin. Is that okay, everyone?
yes, sir.
Very good, very good. So, but you have to note that theta will be in Kelvin. Is that okay? Theta is going to be in Kelvin under thermodynamic scale. Good. So let's see the procedures which I've already explained to you. One, we choose the thermometric property and let it be what? Be X. Choose the thermometric property and let it be X. After choosing the thermometric property and you call it to be X, what you do, now we measure that X. Measure the property at triple point of water. Measure the property at triple point of water and let it be X TR. So after measuring it and you let it to be XTR at triple point of water, we measure the property at unknown temperature theta. We measure the property at unknown temperature theta and call it to be X what? X theta. Then from there, the unknown temperature theta is then calculated from theta equals to X theta over XTR times 273.16 Kelvin. That is, you will have successfully established a temperature scale. Now, before we move to something else, I want us to see if theta is given as 30 degrees Celsius, then in our calculation we shall always be, if we are using thermodynamic scale or the Kelvin scale, our theta must be in Kelvin. Is that clear, everybody? Is it okay?
Yes, sir.
Good.
Yes,
So
sir.
theta should be in degrees, I mean in Kelvin. So to convert to Kelvin, we just add 273. So you add 273 to the one given to you in degrees Celsius, you get in Kelvin. I think that one, we already know it. So if I'm converting from degrees Celsius to Kelvin, I add 273 to it. Good, good, good. Let's move to disagreement of two different thermometers. Actually, when I'm reading physics, sometimes when I'm revising physics, I'm always tempted to reason what it is exactly, and sometimes I find myself just laughing. People, when you're reading physics, don't just read with the purpose of like passing examination. Also read, as you're reading, try to reason out. What are they talking about? In modern physics, there are two scientists. I don't know whether you have seen them. There's a scientist called Bohr, and there's another one called Rutherford. Rutherford and Bohr, they both studied structure of an atom. And these two scientists, they totally disagreed with each other. We're going to reach there and we see, but eventually, all their findings were written and taken into consideration. But the truth is, they all disagreed. And yet they were studying the same thing. Now you see these two thermometers. Do you see these two thermometers? The two thermometers, we are saying that they can disagree even when they are measuring the same what? Temperature. The first time I saw this, I said it is not possible. No, this book is lying. How can the temperature be 37 degrees Celsius? Then you are measuring using a clinical thermometer. Somebody is coming to measure using platinum resistant thermometer. And another one will come and measure it using a thermocouple thermometer. Another will come and use constant volume of fixed mass of the gas in constant pressure gas thermometer. One is getting 37, another one is getting 40, another one is getting 35, another one is getting 30. Actually, when I look at that, I first disagreed also. But finally, I agreed. You people, what is your say about that? Can two thermometers give different readings for the same temperature? If you're there, you say yes. But when you say yes, be ready for the next question, and which is why. Yes. Okay, you say yes or no. Of course, when you say no, you will also be in the point. You also get a question why. Can two thermometers give the same, give different readings for the same temperature? Is that possible? I want to hear somebody say yes. Hello? People are fearing the question why. I know. Alfred, you are not sure. You for you are sure you are raising up your hand. Yes, Alfred. Can two thermometers?
The two thermometers can give different reading due to this one.
Yes.
They have different property.
And so what?
So the one may be using alcohol, then the other one can be using the mercury. So the difference is there.
Oh, good. Let me clap for you, Alfred. Do you hear the clap? Thank you so much. Thank you so much. Thank you so much. Let me hear from another person. Can I hear from another person? The answer is either yes or no. But when you say yes, you have to give the reason. When you say no, you have to give the reason. Who can give us another one? Oh, yes, yes, Benjamin. Yes, Benjamin. Yes.
It's a not to me.
It's not to
Because
you
they all made to measure temperature, nothing else.
because they all measure temperature. Good, thank you, Benjamin. So he says no, they have to measure, they have to read the same thing. Good. Now, as we wind up on that, is there anybody with another submission? Alfred, you can take back your hand. I think you have already given your answer. So, to me, I told you that I agreed after some times. And the answer, therefore, is yes. Two different thermometers can give different readings, even when they are measuring the same temperature. Alfred has already given us the reason. Why? Now, let us compare two thermometers. We have mercury and glass thermometer. It uses mercury. We have resistance, platinum resistance thermometer. It uses what? Resistance. So the way resistance varies with the temperature is quite different from the way the mercury, the length of the mercury varies with the temperature. You get me well, people? The length of mercury, the way it varies with the temperature, is different from how resistance will also vary with what? Temperature. The volume of a gas, the way it varies with the temperature, is different from the way the pressure of the gas varies with the temperature. And due to the differences in the variation of thermometric properties, then they can never give the same reading except at a fixed point, because they are all calibrated or they are all made to agree at a fixed point. So two different thermometers give different readings for the same temperature because two different thermometers are using different thermometric properties, of which these two different thermometric properties vary differently with the temperature. Is that clear?
Yes, sir.
Okay, good. Benjamin, are you still there?
Yeah, I'm still here.
Is your answer now yes?
Yes.
Your answer is now yes. Don't so?
Yeah.
Good, good. Let's see the reason as we move on. We said this is because different thermometric properties vary differently with the change in temperature, but please, this but is important, but agree at a fixed what? At a fixed point. So that's why two different thermometric properties vary differently. So tomorrow or the next day, if somebody asks you, but for sure, Benjamin or Alfred, why do you think when I measure temperature using a mercury glass thermometer, I get 37. But when I use platinum resistant thermometer, I get 40. It is because platinum resistant thermometer is using another property and mercury glass thermometer is also using another property. These two thermometric properties are varying differently with the change in temperature. And so we don't expect them to give the same reading, even for the same temperature. But they will only agree at a fixed point. Is that okay, everyone?
Yes.
Okay.
Yes, sir.
Good, 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 good. Let's see calculation number 1. Do we see the question?
Yes.
It says, Benjamin, can you read for us?
A resistant thermometer has a resistance of 21.42 ohm at
Mhm.
ice point. 29.1 ohm, 29.10 ohm at steam point, and 29.11 ohm at unknown temperature, theta.
Yes.
Calculate the value of theta on the scale of this thermometer.
Good. Thank you so much for reading for us. I will pause the first question before even I start calculating. And the question is very simple. On which scale is this thermometer? Okay, before we answer that, which thermometer is this? Benjamin, you can tell us. Benjamin? Okay, let me pick Magnificent. Magnificent, let me hope that one is your name. Okay, Alfred, which thermometer is that?
This one is resistant thermometer.
Very good. It is resistant thermometer. Now, I'm going to ask Philip. Philip, do you hear me? Philip, do you hear me?
Yes, I hear you, sir.
Good.
Yes.
We have talked about two scales. We have talked about Celsius scales and thermodynamic scale. Okay?
Yes.
We said Celsius scale uses ice point and steam points as the fixed points, and thermodynamic scale uses triple point of water as the fixed point. Is that okay?
Yes.
Now, Philip, on which scale is this thermometer? On which scale is this thermometer?
The first one.
Tell me the name of the first one. Hello.
I forgot it.
Yeah, it's okay. There's no problem. But the Celsius scale, I think that's what you forgot. That's all?
Teacher, I
Yeah.
forgotten.
It's okay. It's okay. But it is Celsius scale. Isn't it? The rest, isn't it Celsius scale?
Out.
Okay.
Isn't it? It is Celsius scale, no, sir? This one is Celsius scale, no, sir?
Yes.
But
Good.
how can we know that this one?
Yeah. To determine that it is a Celsius scale, we say the Celsius scale uses ice point and steam point as the fixed points. Do you hear that?
Yes.
Yeah.
So if the measurement is made at ice point, do you see this? 21 point something at ice point, and then this one at steam point. So that means that it is on Celsius what scale. Is that okay?
Yes.
Good. Now, having known that it's on Celsius scale, you should be knowing that on Celsius scale, you know how to get the temperature on Celsius scale. On Celsius scale, temperature, theta, okay, is equals to, in this case, it's resistance. So we call it to be R theta minus what? R naught over R 100 minus R what? R naught, the whole thing times what? Times 100 degrees what? Celsius. Is that okay, everyone?
Yes.
Good. So a moment I realized that it is this thermometer is on Celsius scale, then I write this formula directly. If it is the length of the mercury thread, I put this one to be L theta minus L naught over L theta minus L 100 minus L naught. Is that okay?
No.
Pardon?
If let's say, if they had said this one is the resistance, but because this one is saying resistance, that's why we have used R to represent resistance, okay? If they say length, then I use L. If they say EMF, then I use E. Is that okay?
Yeah.
Good.
Yes.
Now, the resistance of 21.42 ohms at ice point, that is R naught. Is that okay?
Yes.
It is R naught. Then at steam point, 29.10 at steam point. So that means at steam point, it is 29.10. So that becomes R what? R 100. Is that okay? Then the resistance is 29.11 at unknown temperature theta. Is that okay? So that becomes our R what? R theta.
Yes.
Yes. Then from there, we shall say our R theta is there. So we shall say from x theta minus x naught over x 100 minus x naught times 100 degrees Celsius. It means that theta will be R theta minus R naught over R 100 minus R naught times 100 degrees Celsius. Do you see this now?
Yeah.
Yes.
Good. Somebody's asking which subject is this? If you have just joined, we are in physics 1. Good. So we substitute now R theta. Remember, we had our R theta already. We had our R not already. We had our R 100. We had our R what? R naught. So we just substitute. So it was 28.11 minus 21.42 over 29.10 minus 21.42 times 100 degrees Celsius. Then from there, when you manipulate, who is having a calculator? Who is having a calculator there?
Excuse me, sir.
Yes, please.
Was it 28.11, 29.11?
Let's get there. It was R theta. R theta 28.11. Do you see it here?
So the question is saying 29.11.
Oh, sorry. This was just the typing error. This is supposed to be 28. Is that okay? It is, yeah. So R theta is 28.
Yes.
This is the one which is 28. You see 29 is repeated in the question. Is that okay?
Yeah.
29 has been repeated. Oh, so this is 29 and this is 28. Is that okay? Good. Thank you. So we substitute. After substituting, when you press this, what do you get on the calculator?
Get
87.10.
100.
100. Somebody saying 100. Somebody saying 87. What do you get?
I'm getting 87 point something.
Yes. So you get 87. Sister Miriam, check out your calculator. It is 87.11 degrees Celsius. Is that okay?
Yeah.
Good. Can I move to the next number? Can I move to the next number? Is there anyone with any question on this?
Okay.
Before I go to...
Sir, you
I
can
can...
move.
Okay, thank you. Thank you. So the next number is right up here. The length of the mercury column in a glass thermometer is 2.00 centimeters. At ice point and 2.73 centimeters at steam point. Do you see this one still is a bit Celsius scale? The fact that it is measuring ice point and steam point, it means that it is Celsius what scale. Is that okay?
Yes, sir.
Very good. So they say, no, this time around, it is the length. The first one was resistance. But here it is the what? It's the length. So the length at ice point is this. So this one becomes my L naught. Is it okay with everybody?
Yes.
Very good. At ice point and this one at steam point, this one becomes L what?
L100.
Very good, very good, very good. Go to campus, man. Go to campus direct. So L100. So we have L naught and we have L100. Then they are asking, what temperature on the mercury glass thermometer corresponds to the length of 8.43 centimeters? So this one becomes L what?
L theta.
L becomes L.
Theta.
Very good. Becomes L theta. Good, good,
L
good.
theta.
Very good, very good, very good, very good, very good. So having known L naught, you have known
That one
L.
is to be L theta.
Yes, yes, yes,
Sir.
yes. So having known L naught, you have known L100 and you have known L theta, and they are saying what temperature? So that means they want theta. So what temperature? What temperature is the value of theta? So the fact that it's a thermodynamics, it is a Celsius scale, then I should know that theta is given by L theta minus L naught over L 100 minus L naught times what? Times 100 degrees Celsius. Is that okay, everyone?
Yes, sir.
Yes.
Isn't it becoming porridge? Alfred, do you like porridge at school? Alfred? Okay. Benjamin, what about you?
Pardon the question.
Do you like porridge at school?
No.
Okay, Paulson, what did you say? Which one is your last, your best meal at school? For breakfast. Okay. Me, I used to like porridge so much. So we substitute now L theta. Do you see our L theta? It is 8.43 minus our L naught, it is 2 divided by our L 100 is 2.73. 2.73 minus our L naught, which is still what? Which is still 2. Then times what? Times 100 degrees Celsius. Yes, Mariam, you press for us the calculator and give us the answer. Mariam, Alicia, Arthur, Waswa, you're most welcome. Who has got the answer?
It is 880.82.
880.82 degrees Celsius. Thank you so much. Thank you. Good. So, this is it. Part B was saying that when the temperature above was measured on a gas thermometer, it read 1,200 degrees Celsius. Can we all see that question?
Yes.
Yeah, let me first erase this. When the temperature above, of which temperature was that? We have already determined it, okay? The temperature is 880.82 degrees Celsius. Is that okay? So the statement says, when it was measured using gas thermometer, here it was measured using mercury thermometer. It was found to be 880.82 degrees Celsius. Now they say when it was measured using a gas thermometer, it was found to be 1,020 degrees Celsius. Can we explain the discrepancy? Can you explain the difference in the reading? Can you explain why the temperatures are not the same? That is what they mean by the discrepancy. Who can explain to us? We used the mercury glass thermometer. It gave us 880. Then when it was measured using gas thermometer, the temperature was found to be 1,020 degrees Celsius. That's a very big gap. You can't take it for granted. Who can give us the reason behind? Raise up your hand. Raise up your hand. I will pick you. Who can give us the difference, why there was a difference in the reading? You can raise up your hand. Arthur? Yes, Arthur. Alfred is saying, teacher, help us with the notes, please. Yes, I will send for you the notes from Google Classroom. Don't worry. Why was that? Yes, Alfred Okema.
Yes, sir.
Yes, we are here.
The difference is just the two thermometers have different thermometric property. That one is using the mercury, the gas.
Yes. So very good. It's because the two thermometers are having different thermometric properties. This one is using the length of the length of mercury. And this one is using volume of the gas, whether volume of the gas, whether pressure of the gas. But the way length of the mercury varies with the temperature is different from the way the volume of the gas varies with the temperature. And so the two cannot give the same reading. That's what brought about the discrepancy in the reading. So we say two thermometers which are using different two thermometric properties, two thermometers use different thermometric properties, which vary differently with the change in temperature. Good. So let's see that calculation. We have already seen this. L naught was 2, L 100 was 2.73, and L theta was 8.43. So from theta equals to L theta minus L naught over this, that means that theta will be that. When you divide, you get 880.8 degrees Celsius. So solution to part B, the difference in the reading, the difference in the two readings is due to the fact that two different thermometric properties vary differently with the change in temperature. But they only agree at a fixed points. Is that okay, everyone?
Yes, sir.
Good. Let's go to the next question as we wind up the lesson. It is this. You see question 3? Good. Who has not yet talked in our class? Is there anyone who has not yet talked? Do you know anyone? Alfred, do you know anyone who has not yet talked? At least Alfred has talked. Benjamin has talked. Magnificent has talked. Alicia. We have not heard from you, Alicia. Alicia, how are you?
Yes, sir. Leave not yet.
Even who? Okay, Alicia, are you there? Are you hearing me?
Yes.
Alicia, can you read for us this question? Do you see the question?
Yes, I can see it.
Yeah, read it for us.
The resistance of a platinum wire at triple point water is 5.16 ohms. What will be the resistance at 100 degrees Celsius?
Thank you so much, Alicia. Now, I'm going to ask another person who has not yet talked. Arthur, unmute yourself and say hi to us. Arthur. Okay. Can I hear Waswa?
Teacher, I've been having network problems.
Yes. Okay. Are you okay now, Arthur?
No, I'm still struggling, but I'm hanging in there. I didn't even listen to the explanation when you were explaining.
Oh, sorry, Bambi. Sorry, Bambi, brother. Okay, let me hear from Waswa. Waswa?
Now, be thankful.
Waswa?
The last explanation.
Okay. So what I
Yes.
What I want is that I want to ask, which scale is this thermometer? The question is going to Waswa. Which scale is this thermometer? Waswa? Waswa, we are waiting for the answer. Okay, Waswa is not talking. Who can talk? Magnificent? Magnificent?
It is on Kelvin scale.
Sorry?
Kelvin scale.
Kelvin scale. Good. Benjamin, you can also put your answer. Benjamin?
It's a Kelvin scale.
Very good. The fact that it is measuring only triple point of water, that means that it's on Kelvin scale. And if it's on Kelvin scale, you shouldn't forget that theta on Kelvin scale is given by x theta over x triple point times 270 what? 3 times 273.16 times 273.16. So what we need here is x theta and xt. Good. So if that is the case, then we shall say, if that is the case, we shall say in this question, we have a resistance of platinum wire at triple point is this. So that directly becomes XT-R. It becomes XT-R. At triple point is this. That's why we have it here as what? As 5.16 ohms at triple point. Then they're saying that at the steam point, they're asking what will be the resistance at 100 degrees Celsius. So this 100 degrees Celsius becomes now the temperature theta. So our temperature theta will be the same as 100 degrees what? Degrees Celsius. But we said if you're dealing with thermodynamic scale, it should be in Kelvin. So we convert this 100 degrees Celsius to Kelvin. So it will be 100 plus 273, which gives us 323 Kelvin. Then we use the expression from theta equals to R theta over RTR times 273.16 Kelvin. We substitute what we know. We already know theta, which is 323. We already know R triple point. R triple point is 5.16. And so we are looking for now what? R theta. So we say 323 equals to R theta over 5.16 times 273.16. When you cross multiply and you manipulate, you will get R theta to be that value 7.04. Good. Is there any question? Is there any question?
Teacher.
Yep.
Teacher.
Yes, please. Yes.
What is x theta?
X theta is the resistance at that very given temperature. Is the resistance at the temperature we are looking for. Okay?
Okay.
Yeah, is that fine?
Yes.
Good. Now we shall stop here for now, but before we leave, Waswa is saying that Sir was not around when you were explaining the first work. It's okay, Waswa. That could be the reason why you never answered the other question. So we are going to stop from here, but I have some numbers for you. They are here. Number 1 is here. We have number 1. We have number 2. Sorry, we have number 1. Number 1 is here. Do you see number 1?
Yeah.
Good. We have number 2 is there. We have number 3, number 4, and number 5. So these questions, I will post them on Google Classroom. After this lesson, go to Google Classroom, get the questions from there. Is that okay?
Yes, sir.
Very good. Otherwise, thank you so much for attending the lesson and for being part of this. I call my administrator to come and say something before we end the lesson. Yes, Mr. Bernard?
Yes, well done, teacher Alira.
Thank you. You can say something to our students before they go.
Okay, learners, we encourage you to join the Google Classrooms. If you don't know how to join the Google Classroom, can you raise up your hand? Raise up your hand. Yes, Waswa. Okay, who is using a phone amongst you? If you're using a phone, keep the hand up. If you're using a computer, raise up your hand as well. Okay, put your hands down. Put your hands down. Okay, amongst you, who is able to share screen so that we can see how to put the Google Classroom on our phones? Okay, I'm going to use Waswa. Teacher Alira, stop sharing screen.
Okay, let me remove. Let me stop. Okay, I'm done.
Okay, Waswa, share your screen. Waswa, share your screen. If you are unable, we can get someone else. You go on your Zoom controls, you choose share screen. Among the options, you continue and choose screen. If you are unable, someone else can raise the hand and take it on. Yes, Benjamin. Benjamin, share your screen.
It's telling me that only the host can share the screen.
Okay, share now. Share screen. Benjamin.
I'm sharing.
Benjamin, are you there?
Yeah.
Okay, share screen.
Is it now?
Okay, you open Play Store. Look for Play Store, you open it. It's there, Play Store. Then up there, search for Google Classroom. Search an app, Google Classroom. Google Classroom. Google Classroom. Download it. Classroom is one word. Okay.
I had already downloaded it.
Okay, we are showing you those ones. Okay, then that's how it looks like. Google Classroom is one word. Open it. Open. Since you have already downloaded, open. We have seen how it looks like. So when we open, now here, bottom right, there is a plus there. Click that plus, bottom right. So it tells you to join what? To join class. So click join class. And when you say join class, your class code for senior 5 is T, small t, T, letter T,
T,
then Y, small y, P, small, V, P, 2, figure 2, then P again. Then on top there, top right, join. So those who don't have the code, I've sent it in the chat. That is the code for your Google Classroom. Now you are there. You are there to get all the work that teachers are submitting. At the bottom there, we have stream, classwork, people. Click on classwork at the bottom there. So classwork, that is the work we have so far been posting from the time we started. Click people. When you click on people, you will see your fellow learners and the teachers. Click people. Yes, so the teachers and then the learners are there. So those are your fellow learners. Can we have someone using a computer? You can stop sharing. The rest we shall continue to see how you attempt an assignment. You stop sharing and we see someone using a computer, how to join Google Classroom. Who has a computer? Raise up your hand. The one with a computer? If you're not there, let's call it a day. Bye-bye.